the grade 10 applied math class, we have been learning about graphing linear relations. And we've so far covered two different methods. The first one being a table of values, and the second one working with equations in y equals mx plus b form, and plotting the y-intercept and using the slope to find second and third points on the graph. And today we're going to discuss a third method for graphing linear relations, and this is the method of using the X and Y intercepts. So anytime you have a graph, there are two special points on the graph called the X and Y intercept, and we can see them on this diagram. The X and Y intercepts have been labeled. The X intercept is the point where our line intersects the x-axis. And we can see it's here at -9. And so if we write that as ordered pairs, it corresponds to the point -9 and 0. The y-intercept, using the same definition, is the point where the line intersects the y-axis. And so we are intersecting the y-axis when the y value is 6. So if we think about the ordered pairs for this point, the x value is 0 and the y value is 6. And so that is the definition of an x and y intercept. So let's look at a couple more graphs. Okay, and so for both these graphs, we want to identify the coordinates of both the x and the y intercept. So here is the x-axis. So the x-intercept is at 6, 0, and the y is over here at -2. So that corresponds to the point 0, -2. And when we look at our third graph, our x-intercept is at +7. And this time our y-intercept is at +2, and that corresponds with an x value of 0. So if we look at, I can't get all three of the graphs on the same view right now, but there is some commonalities here. So if you look at the x-intercepts, what do all three x-intercepts have in common? Well, the y value is 0. And similarly, if you look at the y-intercepts, each of the three coordinates that we've plotted has something in common. That is that the x value is 0, okay? So that is the key piece that we need to take away. When you have an x and y intercept, one of the coordinates is going to equal 0. Okay. So far, what we've been doing is we've been reading off the x and y intercepts from our graph. But what happens when we are working with an equation? How are we going to find the x and y intercepts for a linear equation as opposed to a graph? So I'm just going to flip over to the other side. Okay. So what we want to do is we have an equation, a linear relation. I know it's linear because it has an x variable and a y variable, and it's degree 1. So I know that the graph for this equation is going to be a straight line. So we are going to use the concepts that we just saw on the previous page. So at the x-intercept, something's special between all those points. The y value was equal to 0. So now, using our understanding of ordered pairs and solutions to equations in two variables, we are going to find the x-intercept by letting y equal 0. So I'm just going to come down here and go x-intercept, let y equals 0, solve for x. Sorry, yeah, solve for x. So we will write 2x plus 3, replace y with 0. And this is what I mean when we say we replace and we solve. We're using our understanding of what a solution is. with an ordered pair, you choose one of the values for X or Y, and then you substitute it into the equation and you find its partner. Now for the X-intercept, that means we have to let Y equal 0. So we're going to get 2x equals 12. So then x is equal to 6. So over here in this table, I've already said we are going to let y equal 0. So when y is equal to 0, x is equal to 6. And this is our X-intercept right there. Similarly, to find the Y-intercept, you're going to let x equal 0. Any point on the y-axis has a corresponding x value equal to 0. So we're going to let x equals 0, solve for y. So we're going to have 2 bracket 0 plus 3y is equal to 12. So 3y is equal to 12. Y is equal to 4. So that corresponds with the ordered pair 0, 4. I'm summarizing the results in this table of values. But I have intentionally chosen a y value of 0 and an x value of 0 because I want to find the x and y intercepts. These are 2 key points that I want to start including on my graph. Now, if I go and plot these points, 6, 0, and also 0, 4, 2 points is enough to graph this. However, what if I made a calculation error in one of my calculations? Then I'm not going to see it. So what we do is we actually come up with a third point to verify that our calculations are all correct. And so what I have done is I've randomly chosen a value for x. Okay, remember, you get to choose one of the values for either x or y. I'm going to choose x as 3 and find its partner y. So I'm going to substitute that in. So we're going to have 2 bracket 3 plus 3y is equal to 12. So 6 plus 3y is equal to 12. We're going to transpose. And so we clean that up to get y is equal to 2. So when it's 3, we're going to go up to 2. This is looking good because when I get out my ruler, in fact, these 3 points do line up, which is exactly what I want to see. But if I didn't see that, then I would know that there's a mistake somewhere in my work. We add some arrows to show that this continues in each direction. So this is the graph, and we have highlighted the Y-intercept and the X-intercept. So at this point now, you've learned 3 different methods for graphing: a table of values using y equals mx plus b form, and now the concept of the x and y intercepts. So unless you're specifically asked to use one method, you're going to find there are different scenarios when one method is better than the other. So obviously, if your equation is already in the form y equals mx plus b, then that's the method that I want to use. Okay. If it's not in y equals mx plus b, it's in a format similar to what we have where the 2 variables are on the same side of the equation, then finding the x and y intercepts might be a little bit easier to do the calculations for. Now, I've asked that we actually verify that our graph is correct by converting our equation into y equals mx plus b. Now, this is a bit of a heads up of what's to come in the next unit. So I'm sidetracking just a little bit. But when you have your equation, 2x plus 3y is equal to 12. Okay. This is in no specific format, but what we want to do is I want to rearrange this so that y is by itself on the left-hand side. So what we have to do is we have to transpose the 2x to the opposite side, and when it changes signs, it also changes signs. So what was a positive 2x on the left becomes a negative on the right. Now, we have one more step to go. Right now, the mathematical operation between the 3 and the y is multiplication. The opposite is to divide by 3. So I have to divide both sides of the equation so that I can isolate y. So now this becomes y on the left-hand side. And here, both terms on the right need to be divided by 3. Well, -2 does not divide by 3. So we're just going to leave that as -2/3 x. Positive 12 does divide by 3 to give us positive 4. And so now we can see that the slope is -2/3 and the b or the y-intercept value is positive 4. And if we go up to our graph, indeed, our y-intercept is at 4. And to go from the y-intercept to the second point that is marked, we had to go down 2 squares and over 3, down 2, 3 to the right. So what I'm doing here is not emphasizing a second method. I'm just showing you that there's a way to verify your work. We can start using previous concepts to help us and guide us in checking our own work. Okay, let's do one last example of finding the x and y intercepts. So we have another equation. Okay, again, in 2 variables, degree 1, we know that it has to be linear. So let's find the x-intercept. You need to let y equal 0. So we're going to replace the y with 0. So 3x equals 24. Divide both sides by 3. So x is equal to 8. So our x-intercept is at the point 8, 0. And then we're going to do the y-intercept. And any point, the y-intercept is a point on the y-axis that corresponds with an x value of 0. So we are going to replace x with 0. So we will simplify to get -4y is equal to 24. Divide both sides by -4. So we now have a y value of -6. And this is the location of our y-intercept. So finding x and y intercepts is solving an equation where in one instance you let x equal 0, and then in another instance you let y equal 0.